All right, we're going to take what we have already been doing and just put a more generic term to it. All right, so we're still talking z-scores here, but we're going to put this at the z sub alpha. This is just the Greek letter alpha that we're looking at, and it's literally pronounced z sub alpha. So anytime you see that sub alpha, that's an automatic indication that your area is going to the right. That's what that means, that it's the area to the right. All right, so let's write that on. That's what that's going to say. So is the z-score such that the area under the standard number, try it again, under the standard normal curve, there it is, to the right of z sub alpha is alpha. This is the area. That's what that means. They're talking about that area that's under the curve, but it's the area to the right. That's the key right here. All right. So we know that area underneath the curve, proportion, area, probability, all of these things mean the exact same deal, and I'm going to the right. All right. That's the kicker to this one. So if I'm really looking at my area under the curve, right? So this area is, in this instance, because it's this sub alpha, 0.10. That is the area that we have here. That's that area, and that's what we're trying to say. Now, what else do we know about going to the right? That we're using the greater than symbol, right, is equal to that area. So we're trying to figure out what is this value that the value of z, the value that I'm plugging in. Now look at this problem. Does it give me a mean or a standard deviation? No, this is generic z-score. Have we seen something like this before? The very beginning of this section. We take data that we've done before and we normalize it to be a regular z. When we have a regular just z-score that is normalized and ready to go, our mean is 0 and our standard deviation is 1. So let's flip back here to the back. This is just a normal z-score. So given that information, I know my mean is 0 and my standard deviation is 1. That's what we automatically have. The key to this one is this probability here as x is greater than or equal to whatever that value is. This equals 0.10, and it's going to give me that area, that big area that we're talking about here. Okay, so stat, calculator normal, we're still digging on this exact same space that we've always been on. Automatically, look what happens. They're saying, oh, you want just the standard z-score? No problem. We automatically throw it as a mean of 0 and a standard deviation of 1. And we're saying, oh yeah, but more importantly, I want to know what's to the right. That's my greater than symbol, means to the right. And what is that area that we're talking about? That is that 10% area. That's just up here in this little edge. So they're saying, what is my standard deviation to take care of that area? So if my mean is 0 from the middle, my standard deviation goes for 1 every time, then how many standard deviations away from the mean is going to be that top 10%? 1.28 standard deviations away. Do you see that right there? That's what we're being asked. When I have it normalized, oops, too far. When I have this normalized, then this is 1.28. That is what we're actually saying. So here z is equal to 1.28 because I'm talking in terms of what's normal to this curve without specific data. So it all kind of goes together. And so the kicker to this one is when you see this sub alpha, you know it's going to the right. And when it goes to the right, that's that greater than symbol. All right. And the other thing is you have to automatically know these two pieces of data whenever it comes to having a z-score. automatically mean of 0, standard deviation of 1. If you haven't messed with it, StatCrunch automatically does it because that's the common understanding. Cool, right? I know, we're getting so much cool stuff. I'm so impressed.